Okay, now we'll go about taking our data. I do want to state that there was a wire in our figure that I did miss in the setup video. In the procedure notes, it says that we do have a wire in SW2, but it's not connected to anything right now because it's used to discharge the capacitor. I'm gonna just kind of set it aside like that so that I can have it there, but I do want to make sure it's not touching anything because you don't want to let the charge that builds up on the capacitor go until you have set up your capstone equipment. It is time-based, and so we would need to get that data. Okay, you are going to need your capstone monitors for this. If you're going to use the multimeter and a stopwatch, then you'll have to be sure to measure the multimeter and the stopwatch at the same time because you're measuring discharge. This is the best way to do that. So if you still haven't figured out your capstone and your Pasco stuff, now's a great time to get on that internet and figure that out. Pasco has online chat, by the way, so you can even ask the manufacturers how to use it if you need to, but you need to grab this and we're going to set up our voltage exactly where the force diagram said to, or not the force diagram, where the circuit diagram said to set it. So I want to measure my voltage across C7 and C6. That's right here across my capacitor. So I'm going to put one here and one here. Make sure we can still see everything. And then, you know, there's no screen or anything for my capstone monitor. And so you're just going to have to trust me that once it's set up, I will show you the data in class, or we'll try to screen record the data, and we'll also attach what that looks like as it is discharging. All right, the first thing that we should do before we take any readings is make sure our capacitor is discharged, because if it has any charge left on it, it's going to cause an issue. So we want to short the two leads for the capacitor together. Never do this unless you're told to do that. I'm going to hook C5 and C6 together to short it out like this, and hopefully there is no charge left on it. I can even do this. I'm just making sure it's shorted. All right, so there should be no charge left on the capacitor, and so I should be able to close the switch by holding my button down, and the voltage will change with time. Now, when I close the switch, there's nothing you're gonna see here. So I'm gonna pause it and we're gonna show you the computer. All right, so now I have my setup so that you can see my computer. I'm gonna close my switch and hopefully everything works the way it's supposed to. 3, 2, 1, close. Well, crud. All right, I forgot to click record. So I need to discharge my capacitor again because I did just charge it up and I don't want it charged. So I'm gonna short my capacitor out and pull any charge out again. Short, 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 short. Okay, so it should be shorted. I'm actually even gonna move this because right now it's not important. So now I should be able to click the button again. I'm gonna click record and we're gonna see if it works. All right, so we're gonna click record, and then I'm going to click my button, and you can see the voltage increasing in the negative direction because my leads are backwards, and it should increase until it's charged. Okay, I think that's getting to be pretty stable. Let go of the button. You'll notice that the voltage stays the same because it's storing. Oh, it's slowly gonna go back down now because I turned it off. And just to show you that there is a steady leak of voltage over time due to the fact that we're in Houston and it's humid and a bunch of different things. But for the most part, that should hold steady. The last step is to take the extra wire that we had and connect it between SW2 and C5. And you'll notice that your voltmeter is going to exhibit a more significant drop. because what we are doing is we are discharging that capacitor. And the discharge should have the same type of relationship that the charging does.